Hello everyone, welcome to Understanding Physics, in which I will try to guide you through understanding physics. So today I want to introduce classical mechanics, in which we are discussing about how things move, as well as the interactions between moving objects. And so in this entire series, we'll be discussing about classical mechanics, and the book that I'll be using is Classical Dynamics of Particles of Particles and Systems. And this book is made by Thornton as well as Marion. And so I'll be using the 5th edition for the reference. And so if you want more practice as well as visuals or more examples, you should go ahead and refer to the book since it is where most of the source is coming from. And so I want to discuss about classical mechanics between 14 different videos. So first we'll be discussing about matrices, vectors, as well as vector calculus. And so these are things that we have already discussed in foundational mathematics, but if you only want the mathematics you need to do classical mechanics, you could just refer to this video. After that, we'll be discussing about Newtonian mechanics. And so Newtonian mechanics is the thing that we normally use throughout General Physics 1. And so in here we'll be focusing on single particles, but then later on we'll be developing the idea for multiple particles. After that, we'll be discussing about a very special movement, which we call as oscillation. And then later on, we will be discussing for something which is a nonlinear oscillation. And this idea of nonlinear oscillation will later develop into the idea of chaos. So we'll later be discussing about a chaotic system in which it really depends on the initial condition. After that, we'll be discussing about gravity, so gravitation. And so everything that we'll be discussing from chapter 2 to chapter 5 is something in which we have already get a very small glimpse in General Physics 1. But after that, we'll be using some much more advanced mathematics. And so on chapter 6, we'll be discussing about another mathematics in which we call as the calculus of variations. In which we'll be discussing about methods for you to do the calculus of variations. After that, we'll be discussing about Hamiltonian, Hamilton's principle, in which this is the basis of Lagrangian and Hamiltonian dynamics. So this is a much more advanced way for you to solve a mechanics problem. After that, we'll be discussing about the central force motion. So we'll be discussing about how do you convert multiple forces into a centered motion, as well as the reduced mass and etc. So this is for you to discuss about multiple objects. After that, we'll be discussing about the dynamics of a system of particle. Dynamics of a system of particles, in which we'll be discussing about the conservation of momentum and collisions and other things as well. After that, we'll be discussing about motion in a non-inertial frame. And so this discussion is important since if you are referring to a certain event with a non-inertial frame, this would mean that you would create fictitious force. And we'll be discussing about this throughout this chapter. After that, we'll be discussing about the dynamics of rigid bodies. So the objects will always be the same. It won't deform, And so there is a very special field in physics for this. After that, we'll be discussing about coupled oscillations. So this is where the idea of oscillations comes together, and 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 it will transfer information from one oscillation to another. So this is why we call it as a coupled oscillation. After that, on chapter 13, we'll be taking coupled oscillations further into the idea of a continuous system. And a characteristic of a continuous system is waves. And so this is where the discussion of waves will come in. Finally, we'll be discussing about special theory of relativity. Same idea from classical electromagnetism. Special theory of relativity. So the way that you do mechanics, especially when you go approaching to the speed of light, is very different compared if you're doing it with classical mechanics. So this is the entire chapters that we'll later discuss throughout classical mechanics. And so that's all for this introduction video. So make sure to like and subscribe, and also share this to your friends who wants to understand classical mechanics in a deeper understanding. Thank you very much for watching, and I will see you on the next video.